justification for why the formula is what it is. So when we're talking about double angle, that's like 2 times an angle. Okay, so if I said cosine of 2a, do you guys agree that 2a is the same as a plus a? Okay. What is the cosine of a plus b formula?
Cosine A, cosine B, minus sine A, sine B.
Okay, right? Cosine of the first, cosine of the second, minus sine of the first, sine of the second. What is cosine A times cosine A?
Cosine A. Or
Cosine A squared.
Cosine squared A. And sine A times sine A is?
Sine squared.
Oh, so it's 1.
When they're adding, it's 1.
Oh, wait. Well,
0.
that's on me.
No, not necessarily. Only if you were looking at like 45 degrees or something like that.
Oh, the angle matters.
Yes.
I know.
So, this is the first formula, and I'll put all of these up on one slide here in a second when you get ready to write in your flip chart. So I'm just giving you a little justification. This formula can be manipulated. There's actually 3 different versions. Because if we have cosine squared minus sine squared, isn't cosine squared the same as 1 minus sine squared? And negative sine squared a and negative sine squared a is negative 2 sine squared a. So that's another possible double angle formula for cosine. On the other option, what could I replace sine squared with?
Minus cosine squared.
Okay, if you distribute that negative,
You get 2 cosine.
2 cosine squared a minus 1. So there's actually 3 different variations for cosine of 2a. You can use any of them, you'll get the same answer. Typically, we use whichever one is easiest in the problem. So like if I give you a value for sine a, we'll probably pick the formula that only has sine. If I give you a cosine, we'll probably pick the formula that only involves a cosine. So we'll just kind of pick those to be convenient. The others we can do the same way, like the sine of a plus a, or sine of 2a formula, we can make it a plus a and use sine to expand it. Same thing with tangent. Do you guys want me to prove all of them, or kind of okay, understand the process where they all just come from the sum and difference identities? So these are the 5 double angle identities that you need to write down on your flip chart. Alright. So I'm going to give you that sine of theta is 2 over 5. Cosine of theta is less than 0. I want to find sine 2 theta, cosine 2 theta, and tangent 2 theta.
Can we plug in right now? Or do it?
Can we what?
Oh, never mind. I answered myself. I understand now. I thought that was, I didn't see the comments. I thought it was an equation.
Gotcha. So, sine 2 theta, the formula you just wrote down, if you change your a's to theta, is 2 sine theta cosine theta. I gave you what sine of theta was. But if we're going to finish this, we need cosine, correct?
Mm-hmm.
How can I find cosine of regular theta? Not cosine 2 theta, cosine of regular theta.
Oh, we just like, we just drew the other side, right? We said equal. It's better now.
Sine is y over
However, R.
Mm-hmm.
and cosine is x over r.
Mm-hmm.
And then something about r being 1.
That's on the unit circle.
Okay.
R is 1. We actually did problems in chapter 1 where I would give you this and say find cosine.
I remember doing it. I just don't remember how.
And there's different ways. We could go like back to x, y's, and r's. A lot of times we just did triangles. If cosine is negative, what quadrants is cosine negative? But sine is a positive. So it has to be which of those?
2.
Okay, so if I thought of this as a triangle, this is for angle theta. SOHCAHTOA, sine is opposite over hypotenuse. So my opposite side is 2. My hypotenuse is 5.
Oh, so now we just got two.
Can you find that? Yeah.
Square root of 21.
A squared plus 2 squared equals 5 squared. Okay, when you do the square root, you have to do plus and minus. Would it be positive or negative here? So this side is a negative radical 21. So what is cosine of theta?
Negative radical 21 over 5.
Oh,
Adjacent over hypotenuse. Is it coming back?
Yeah.
It's been a while. That was our very first unit when we used that.
Man, I thought we were done with that.
Nothing goes
Oh,
away.
cool.
So 2 times negative radical 21 would be negative 4 radical 21. 5 times 5 is 25. So sine 2 theta is negative 4 radical 21 over 25. Are you okay back there?
The whispered sorry.
Cosine 2 theta. There's 3 different formulas. You can pick any one you want. So just pick one. What do you want to do?
2 cosine squared A minus 1.
So if we do that, what would cosine of theta be? Negative radical 21 over 5 squared minus 1. Negative radical 21 times negative radical 21 is a positive 21. 5 times 5 is 25. Okay. So 42 over 25 minus 1. Get 17 over 25. And if you'd used one of the other formulas, you would have got it as well. For the tangent to theta, we actually have 2 different options. We can use the tangent to a formula. If we did that, tangent to theta is 2 tangent theta over 1 minus tangent squared theta. If I'm looking at my triangle, tangent is opposite over adjacent. So that'd be negative 2 over radical 21. I have to do some cleaning up here. Over 1 minus negative 2 over radical 21 squared. Negative 4. Can I write that as negative 4 radical 21 over 21?
Yes.
Bottom would be 1 minus. If I square that, negative 2 squared is 4. Radical 21 squared is 21. How do we divide fractions?
Reciprocal.
What happens to my 21s? I get negative 4 radical 21 over 17.
Where does 17 come from?
1 minus 4 over 21. Can anyone think of another way we could have gotten?
We can just use the other
Cosine
tangent
over the
formula.
cosine.
What's wrong, Kate?
Where did the 4 from?
When I took negative 2 over radical 21 and squared it. Okay. since we already have sine and cosine for 2 theta, we also know from our other identities that tangent of 2 theta would have to be equal to sine of 2 theta over cosine of 2 theta. And we found sine of 2 theta was -4 radical 21 over 25. We found cosine of 2 theta was
17 over 25.
if you flip and multiply, those cancel and we get the exact same thing. Which one's easier?
The second one.
The second one. But this only is really helpful if you had to find sine of 2 theta and cosine 2 theta as well. If the only thing the problem had asked me to do was find the tangent, it probably would have been easier just to do the tangent formula. So, couple of options there. Are there questions on that one? So I have lots of examples built into this. Do we need another one like this, where I give you one of those trig functions and for regular theta, and we have to find all the double angles? Do we want another one? Nobody's gonna say yes. Nobody wants to do the one. I've got a lot of them ready if we need it. Let's do this one.
Oh, there's a big drop.
Find the 6 trig functions of theta if cosine 2 theta is 3/4 and 180 is less than theta is less than 270. The trickiest thing here is knowing that 2 theta and theta are 2 different angles. Okay, so you have to keep those straight. If I am talking about theta being between 180 and 270, what quadrant is that in? Okay, that's not 2 theta, that's the quadrant for theta itself. Alright, I want to find all 6 trig functions of theta. I can do that if I can find at least one of them, because then I could set up a triangle in quadrant 3, and once you know one of the trig functions, you can find all your sides and do your SOHCAHTOA. So cosine 2 theta has 3 different formulas. When I'm looking at these,
Do the first.
there's 3 options. 2 of them are okay and 1 is not. If I use the first one, I know cosine 2 theta. Do I know cosine of regular theta? Do I know sine of regular theta? Can we solve for 2 unknowns at a time? No. So we don't want to use this formula because it just has too many unknowns. But we could go with one of the other 2, and it doesn't matter. Do you guys have a preference? This one? Okay. So we decided to use cosine 2 theta equals 2 cosine squared theta minus 1. So we plug in what we know. I gave you cosine of 2 theta. So that gets replaced with 3/4. I'm solving for cosine. So add our 1. To get rid of the square, we square root. With that, we have plus or minus. How do I know which one it is?
We're in quadrant 3, so it's minus.
Cosine's negative in quadrant 3. Square root of 7 over, how do we break apart square root of 8?
4 and 2.
So we could change. Can we leave it like that for our final answer?
No, multiply.
So we found that cosine is negative radical 14 over 2 times the square root of 4, so 2 times 2, which is 4.
Now we can do triangle.
Alright. If I know cosine, what other trig function do I know automatically? Secant. Is the reciprocal. So that would be negative 4 radical 14 over 14. Negative 2 radical 14 over 7. Okay. So if we think about our triangle, cosine is adjacent, so that would be negative radical 14 over hypotenuse. Remember, hypotenuse is always positive. How do we find our missing side?
Square, you know, 7.
A squared plus b squared equals c squared. Square root, with that you have to decide plus or minus. Which one would it be here?
Minus.
Because in quadrant 3 you're going down. So it's a negative.
It's double negatives.
Okay, so now we use our triangle to finish. Sine is opposite over hypotenuse, so that would be negative square root of 2 over 4. And if you know sine, then you know
Cosine. Cosecant.
negative 4 over radical 2, or negative 4 radical 2 over 2, which is negative 2 radical 2. And we could also get tangent. We could do sine over cosine or opposite over adjacent. So negative square root of 2 over
4.
negative square root of 14. Negative divided by negative is positive. They're both under radicals, so we could divide them. So we get radical 7 over 7. Which cotangent then would be the square root of 7. So this is kind of a mix of old and new. New stuff starting with that double angle formula. Old stuff setting up a triangle and finding all the missing pieces. Yes.
So like, what's the difference between doing this with the triangle and doing like the with the twos?
So why didn't we just start with triangle at the beginning? Is that what you're saying?
Like we did a triangle for both, but like, what's the difference between doing it with twos and doing it just finding?
It's what the angle measure is. So if theta were 10 degrees, we just found all of the ratios at 10 degrees. If you done it with 2, it would be 20 degrees. So it's just 2 different angle measures. So your sides turn out different.
So
Well, if
what's,
your angles are different.
so what's the point of realizing that theta is in quadrant 3 is only like regular theta is in quadrant 3 and not two theta?
Because I asked you to find the trig functions of regular theta. So I didn't ask you to find sine of 2 theta.
So
I asked you
if
to find
we-
sine of regular
So
theta.
if we had, for example, that same question, right?
Uh-huh.
Except 6 trig functions of 2 theta,
Then
would
we,
we have to change the
quadrant.
quadrant?
Yes, we would
Figure
need
that
to know
out.
what quadrant 2 theta was.
Okay, so just make sure that that matches with the what it's asking
Mhm.
for. Okay.
Other questions here? Can we do another one? Absolutely. I am prepared for that.
I don't think I've personally heard that.
I wanted to do another one too.
Thank you.
You didn't verbally express it though.
I did.
You didn't need to. She did it for me.
I
Because
didn't.
I wanted to do it.
Oh, I put an equal to. Oh my gosh, we're equal to 2. Oh my god, I keep driving drawing less than or equal.
I would rather know what would do.
Okay.
So like, Carson's gonna make his own way.
If I look at this, I am asking this time for not all 6, just sine of theta and cosine of theta. What quadrant is theta in?
Two.
So we have to get sine of theta and cosine of theta. we have to have some starting point. The only information I gave you was about 2 theta, so that's the only reason I'm starting with that 2 theta formula.
Would you do the one with sine this time? You know,
Sure.
that's with cosine.
So we could, what is the formula for cosine 2 theta involving only a sine?
1 minus 2 sine squared.
Okay, so now we plug in what we have. Cosine of 2 theta gets replaced with
What about
4/5. If you subtract 1, 4/5 minus 1,
negative 1/5?
divide by negative 2,
Is that negative 1/10?
becomes a positive 1/10. Okay, square root plus or minus.
Sine, so it's positive.
Right. Our angle is theta. So we need to know the quadrant for theta. Theta is in quadrant 2, sine is positive in quadrant 2. So we could turn this into radical 10 over 10. So you could really go back to your identity and do the cosine one, like the cosine 2 theta equals 2 cosine squared minus 1. Or we could set up the triangle here, it doesn't matter, we have a lot of options at this point.
Triangle is.
How did you get, why did you turn the 110 into the radical 2?
So the square root of 1 is 1 over the square root of 10, and I was just getting the radical off the bottom.
Sine's opposite.
So SOHCAHTOA, sine is opposite over hypotenuse.
So we do the Pythagorean.
Mm-hmm. Square root, we could break 90 up into 9 and 10. Would it be a positive or a negative?
Negative.
Think about if you're plotting points in the x-axis, you're going backwards. So cosine adjacent over hypotenuse would be negative 3 radical 10 over 10. So once you figure out one, the triangle is your fastest bet for getting it, all the others.
Can we also think about how cosine, oh no, never mind. She's asking why is it negative?
Because if you're plotting points and you go backwards, x is negative.
Okay, x on this side.
It's like it's positive, positive, negative, positive, negative, negative, positive, negative. You know how
Think about like if you are graphing. Okay, if I take this point, it's positive 2, positive 3. If I take this point, it's negative 3, positive 1. So the x was negative because we went backwards. If you're traveling along the x-axis.
So the negative 3 is just like the x.
I love traveling in graph.
Yeah, negative.
Are we okay?
Simply the best way to travel.
We'll figure it out.
It takes a little bit because all of a sudden we are pulling in a lot of things that we've done before. It's not just the one new piece, it's the new piece and all the stuff that we did in previous chapters. Okay. Let's look at let's try this.
It's not, that's not beta, is it?
It's beta, yeah.
It is beta?
Yeah.
It's a B. That's why I know. I hate drawing beta though, because it's weird.
Difference in squares question?
No, this was a formula.
Theoretical.
So what am I asking you to do on this one?
Verify.
It's a proof.
It's a proof.
So we have to box in a side. Which side should we box in?
Cosine's 2b.
Right. What do you want to do with the left?
Difference of squares.
The square is
Okay.
Cosine's right.
Cosine to the fourth would break into cosine squared. 1 would be plus, 1 would be minus. What's sine to the fourth break into?
Sine squared.
What is cosine squared plus sine squared?
There's 1.
What is cosine squared minus sine squared?
No, that's a.
It's the first double angle identity wrote down. And 1 times cosine 2 beta.
It's cosine 2 beta.
Oh, cosine 2a. Cosine 2a is from
Oh,
What's wrong?
How'd we get there? The 1 and the cosine, you mean?
From our identities. So
Now you're
This-
gonna get-
was that first Pythagorean identity. Cosine squared theta plus sine squared theta equals 1.
Grant has got his magnifying glass out.
Okay, I got
This-
that side. I got that side.
Is the first double angle identity.
Oh wait, it's on
Okay,
the
that
front.
makes sense.
It's on the
Ah.
I saw Grant.
what would you do?
Like, with
Could
this.
you do it some way from the other side by turning cosine 2 beta into
You
like a
can.
formula, but like how would you get it?
Then you would have to just realize I mean cosine to the 4, so you just have to introduce a cosine squared plus sine squared in because it's equivalent to 1.
So one of these is like 1 minus.
It would be tricky.
Just multiply all.
Yeah.
I constantly think about taking something that's verified with a 1, and I really
I
think about
work
going
backwards
with it.
from
I
that.
just think about it so much.
Okay, do we want another proof example?
Yes.
Okay, let's try this one.
Oh, hello. Oh, would that make it into not nonsense?
Okay. We have to pick a side.
I don't think there's anything we do with the right box to write in.
Box the right. Okay. With the left, what can we change cotangent of x to?
Cosine over sine. And there's no sine cancel out, was there? Or different, no.
They're different. What can you change sine 2x to?
2 sine A, cosine A? Or 2 sine X, cosine X.
So this is the double angle identity for sine. Okay. Now what?
Distribute?
So if we multiply, we get 2 sine x cosine squared x over sine x. What happens?
One of the sine x's can cancel.
Sine just cancels. It's cosine squared.
Is it 2 cosine squared? Oh, that makes 1, because it's squared, you just, is that Pythagorean, isn't it?
It is, it can go to 1 minus sine squared. Is that closer to where we're going?
No.
What do we do if we get stuck?
We box it in and go to the other side.
Box it.
Let's try.
Box it in.
Okay. So let's look at our identities. Cosine 2x. We have 3 possible formulas. If you look at where we're going, I want a cosine squared in it. So which identity would you use?
2 cosine squared A minus 1.
We wanted,
Oh,
can you
cosine.
repeat what you just said, sorry?
We have cosine 2x.
Uh-huh.
So we look at our identities. It's a double angle. We have 3 choices.
And we want the one.
We want the one with cosine.
Okay, thank you.
Didn't you just like mumbo jumbo
Shoot, the
the
ones-
second one up for the plus side?
Yeah.
The 1s cancel out.
One's cancel.
Two cosine squared x.
If that minus one equals cosine squared, then that plus one equals cosine squared.
I always forget to look at it as two separate. I always look at it as one now for some reason. Like it's a Pythagorean or something.